Hello everyone. Today we're going to talk about big data. So what is big data? The meaning of big data refers to data that contains greater variety, arriving in increasing amounts, and with more velocity. In simple words, big data refers to a big chunk of data. Nowadays, we have generated even over 5 times 10 to the power of 21 bytes data via online activities. Our DNA contains 10 to the power of 19 bytes data. Comparing to the total big data volume that our society generated through online activities, we can say that big data contains 500 times more information than a complete, extremely complicated human being. With this in mind, let's begin today's video by talking about how to use scientific ways, such as data science, to study big data that can help our social science research, such as predicting the inflation rate, scientific research, such as analyzing biological environment, and to help our society advance significantly. The first thing we're going to talk about today is big data in the science of our lives. For demonstration, I set up a coding project for this ASP video. So in this setup, one dot stands for one data point, which includes the race that the person is coming from, as well as the tolerance level the person has towards having different race in the community. So different colors stands for different race, and as time passes by, we can see that people are more likely to form communities within the same race. Big data plays an important role in helping developing this theory called ethnography segregation. So big data can track different individuals' tolerance level towards having people from different race in their community. This theory and how big data is so important in this theory will later be explained by me and my brother. So here, my brother and I will demonstrate how to use big data to analyze and predict the excludability of our society. So through big data and through analyzing the data online, big chunks of data online, such as his browsing history, such as his birthday, which shows he's a Gen Z and he's more likely to be open-minded, such as the countries he have traveled. All this information he has posted online, we can find using big data. And using these big data and we analyze them through data science, we can find out his tolerance level to having different foreigners and different race of people in his community. Let's say his tolerance level is 50%, which means he's able to accept 50%, at most 50% of the people in the community to be non-Norwegian. So let's say I have two Chinese friends, Chinese friend A and Chinese friend B. He has two Norwegian friends, Norwegian friend A and Norwegian friend B. So the theory will show that because his tolerance level is 50%, so he and me and Chinese A will become friends, and that's within his tolerance level. And I will become friends with him and Norwegian friend A. But since the other 50% should be within the community, within the same race, so he will have two Norwegian friends, I will have two Chinese friends, and these two Chinese friends will also have two Chinese friends and 4 Chinese friends. So in this case, the community of Chinese community will expand. Now, let's go back to the model and set it up once again. At first, every individual is randomly located on this planet, and as time passes by, people will move around and find the community that they fit in. And at last, individuals will form communities that is formed by people from the same race, and there will be larger communities, generally speaking. So first of all, without big data, we won't be able to find this model in the first place. Secondly, without these huge amount of data, we won't be able to analyze and find out the tolerance level of people in the reality. So if the tolerance level is high, the government can therefore predict that the society will be formed with lesser communities, but they have greater size and more race of people in general. So if the tolerance level is low, then the government can be able to predict that the society will be formed with more communities in general, and they will be formed by single race people, and they will have diverse cultures. The second thing we're going to talk about is big data and natural sciences. So physics has been dealing with large volumes of data since before big data became a buzzword. In the 1960s, high-energy physicists looking to understand the particles and forces that make up the universe pioneered the use of computers for data acquisition, simulation, and analysis. Today, the Large Hadron Collider, LHC, CERN's flagship particle accelerator, produces 1 billion particle collisions per second. These collisions provide a window into the fundamental constituents of the universe by generating more than 30 petabytes of data per year. These data are accessed by a community of thousands of physicists around the globe in near real time through the world's largest distributed computing infrastructure known as the worldwide LHC computing grid. Another example of using big data to find patterns would be the European Space Agency's Gaia
satellite, currently measuring the positions and motions of more than 1 billion stars in the Milky Way, automatically recording and finding relations between the stars, helping physicists develop their stories more easily by providing analysis and patterns of the star's movement. As science and technology develops, big data will play a more important role in helping science in the future. So let's look forward to see how big data will help us in scientific research in the future.